Bismillahirrahmanirrahim. In this short video, I will just give you some introduction about the flight data recording system on the aircraft and how the data is collected from different sensors and aircraft systems and goes into the flight recorder in which format, and then how it's been retrieved and then converted back into the actual engineering parameters. So there are several steps. We will go one by one through each slide. The second flight data recording system is a requirement by ICAO that it should be installed with different parameters, mandatory parameters that should be recorded on the recorder to investigate any incident or any happening on the aircraft during flight or on the ground. So the recorder starts operating. Normally, there are two ways. One is through the anti-collision light. Whenever it's on, it will start, or whenever the power is on, it will remain on for a certain amount of time, or whenever the engine start lever is put to on position, it will start recording. And the last way is that from in the cockpit, if you put the on the FDR panel, you put the switch to on position, it will continue start recording. So the next slide. So the aircraft data is coming from different sensors and it goes to aircraft systems, which converts them into the digital format. And then it goes to the FDIMU, which is a unit in the aircraft in A320, A330, which converts them into Arinc 573-717 format, which is specific for flight data recording. We will discuss it in the later slides. What is 573 and how it is configured. So 573, when it was initially designed, the number was 573, and it was recording at 64 words per second. Later on, when the speed of the data increased, it was renamed to Arinc 717. So normally you will see Arinc 573/717. So 573 is only applicable for 64 words. Anything above 64 words, 717. 573/717 Arinc is a serial data format. It records data in frame-by-frame format. Each frame is a 4-second long. Each frame contains 4 subframes. Each subframe contains number of words based on the speed, like 64 words, 56 words, 512 words, 1024 words. So normally in T320 and 330 we have 256 words per second. In 777 also, in the older versions, it was 256 words per second. And in some freighter 330, I've seen 512, and 350 and 380 contains 1024 words per second. Each word consists of 12 bits. So each subframe, which is coming in a second, contains first word is a sync word. So if you know about serial communication, for synchronization purpose, we need some methodology. Sync word is one of the methodology, that the first word of every frame should be a permanent word, fixed word. So whenever a receiver is trying to receive the data, it will search for that sync word. As soon as it finds the sync word, it knows that it's the first frame of a particular subframe. And later on, it will just read the rest of the words, and if it is 256 words, it will read the 255 words, and then the second subframe starts, and the first word of that subframe will be a synced word, which will be a different synced word than the subframe one, and then so on. So it is actually for the listening side is an aid to recreate the information which is coming from the sender side. This is the breakup. The one frame is a 4-second timing, and each frame consists of 4 subframes, and each subframe consists of number of words, which is based on the number of the speed of the transmission, which is 256, 512, 1024, whatever. So if it is 256, the first word in every case will be a sync word, and it will go on till 256, and then the second subframe will come, second subframe, and the first word of that subframe will be a sync word. Each word in all the frames consists of 12 bits. So how we recreate raw data into engineering information. Once a raw data is downloaded from FDR, the data inside the file is searched for sync words to generate a frame. Once a complete map is generated by the software, data in each word is processed as per the information provided by the aircraft manufacturer to generate engineering report. The data contain following different types, like binary data, discrete data, BCD data, ISO coded data. Binary data is a continuous data like EGT, pressure, etc. Discrete is a single bit information which is on, off, open, close, etc. BCD is a binary coded decimal like date, month information, flight number, etc. ISO coded is a value of data shows different information like which ECAM page is selected. This is a sample of information provided in the FDRPL provided by the OEM. It tells you that, for example, if you want to see the airspeed in a raw data, how do you know? So airspeed is contained in word number 19. Subframe number all means it is available in all subframes. And then you will see bit number 1 to 12. In some of the words, it's 10 bits from 2 to 12 or 3 to 12 was. So one sample per second. And then it shows that if the decimal value, raw value is 0, it is 0. If it is 2047, it's 512. 4095, 1024. It's like a simple linear equation. Y is equal to mx plus c. So c in this case is 0, constant is 0. And the multiplier is 0.25006. So you have to put all this information inside your software so that it knows that if you ask for airspeed, it will see the 19th word, subframe 1, 2, 3, 4, bit number 1 to 12, multiply by this, and it will find out that the airspeed it will display is the actual engineering airspeed. If we discuss about the cost, several softwares are available in the market from OEMs like Honeywell, from L3 Communications, third parties like Flight Data System. So they charge a lot of money. If you want to buy a software, they will charge around $20,000 one-time license fee for one computer, and there will be an annual servicing charge of around $5,000, which varies from 2,000 to 5,000 uh, from vendor to vendor. So $20,000 is one-time cost, and it is the minimum cost. For L3 it is higher than 20,000. It's around 40 or $35,000 for Honeywell as well. The third-party software, FDS provides a lesser cost because they are not the OEMs, so they charge around $20,000. And we purchased in my previous company in 10 years ago at $15,000 and $1,500 annual subscription charges. Later on, the company has been shifted from UK to USA, and they increase the charges a lot. Then this software process each word subframe as per the information provided, as we discussed before. So it means that that software needs that FDRPL information as well. And you have to feed that information one time for each aircraft. Like you have A320, 330. So for both of the aircrafts, if you have the same versions, the basic database will be the same. For different versions, might be some parameters will be different. But if you have an old version of 320 and a newer version of 320, it might have a big difference between the databases. Like in one of the type was 256 words per second and another type was 1024 words per second. Depends on what type of equipment installed on that aircraft. So that information, either you have to put that information by yourself, which takes a very long time. And if you outsource it for outside to the OEM, they charge a lot of money, which costs around 8 to 10,000 US dollars for just putting that FDRPL into the software. for 256 words per second of the size of the information. So we know the philosophy, how the data has been saved inside the and how we have to retrieve that information from the FDR raw data. So I have an experience of around 20-25 years from working on these different softwares. From Honeywell, we used to use a DRAS system, and then for L3 we have ROSE, and then I have worked on Star software from FDS as well. So all three are different with different graphic user interfaces. Same output, same everything. Some are very difficult to use, some are very easy to use. But the functionality inside the software is exactly the same. So we have designed our own software locally. I will give you a demo as well afterwards. This is much simple, much cheaper, will be much cheaper than the available softwares, much easier to use and much faster because we are using the latest Python libraries, which are much faster in processing the data, and those libraries are used for machine learning data processing as well. So they are quite fast. So the information which we used to convert in the previous software, in Honeywell software or L3, they are using older libraries and they are very slow to process the data. So it takes a lot of time. But you will see it is much faster here in our software. And as it is a local design software, it's possible to change the layouts or anything as per the user requirement. So it's very easy and it gives you the flexibility to select any portion of the information from the data, and it's much easier to use. You will see in the demo. So when we go towards the demo, it's just a simple introduction about the system and what we are doing. Thank you very much, and we will see the demo.